ladies and gentlemen, good evening. My name is Kalina Kościanek, and I'm a second-year student of biology at our university, and I'd like to start off with asking you a very simple question. What springs to your mind when you hear the term zombie? Do you think of a hand crawling out of its grave, or maybe a greenish-looking person walking slowly with his arms out, or what comes to your mind is an insect infected by a fungus? Well, if you thought of the latter, you are thinking like a true biologist. So, without further ado, let us explore the world of entomopathogenic fungi. So, what hides behind the term zombie? The closest existing form, similar to zombies in our world, are insects that are under the explicit control of parasitic fungi. These entomopathogens use special techniques to manipulate their host behavior to increase their success in transmission, and this phenomenon is called active host transmission. So there are three main strategies that are known today, of three different types of fungal infections, which are active host transmission, which I just mentioned, summit disease transmission, which I will dive into a bit more later on, and non-manipulative transmission, which is simply put when a fungus infects an insect, the insect dies, and then the spores are dispersed passively by the environment. So what actually is active host transmission? So it is when the fungus, after infection of an insect, manipulates its host behavior to increase interactions with other individuals so that it can infect more insects. And on top of that, the spores, so the fungi's reproductive structures, are dispersed while the insect is still alive. Well, how is that possible? It is actually quite tricky because the fungus is developing inside the insect body, and it must do it in a way that doesn't disrupt the functions of the insect's vital organs as well as muscle or ruin the exoskeleton. So a great example of active host transmission is the infection of cicadas by the Massospora fungus, where in the first stage of the infection, you cannot in any way differentiate an infected cicada from a healthy one. Later on, the abdomen swells up and eventually falls apart, revealing the fungus that has been growing within. Then the cicada is going around doing its usual daily business, and the spores fall from the abdomen-like structure and can infect other individuals. Apart from that, what I find truly fascinating is that this fungus can actually change sexual behaviors of male cicadas. So what happens is they change into extremely desperate females. So in the reproductive season, they respond to male calls and start flicking their wings very loudly so that they let know males that are nearby and that they can come over, and then through copulation attempts, they infect other individuals. Another great example of AHT is the strongylcy fungus that infects flies. And this fungus works in this way that it penetrates the fly's abdomen, creating these holes you can see on the picture there. And while the fly is going around and flying, as they usually do, the spores fall out like parachutes from its abdomen, falling on vegetation or other flies, infecting more and more individuals. And another very peculiar form of fungal infection in insects is summit disease transmission, where spores are dispersed after host death and are also dispersed passively by the environment. So you can wonder, what is the difference between this and regular non-manipulative transmission, which is most common? The answer is, before the host's death, the fungus positions the insect so that later on the insect cadaver is positioned in a way that facilitates the spores' dispersal. And the most popular example of zombie-like insects you may have heard of is the Ophiocordyceps, which infects ants. And this is actually very interesting because upon infection, the fungus makes it so that the ant leaves its colony, but not too far away. Then the ant walks around really wobbly and tipsy and starts climbing vegetation that is near the ant nest and stops approximately 20 centimeters above ground, bites into a leaf or a stem, and dies. And after the death of the host, the fungus grows out of the cadaver and disperses its spores. So you may wonder, how does the ant stay fixed to the vegetation if it dies and the muscles should release and the ant should fall? Well, this fungus penetrates through the muscles surrounding the ant's mandible and makes it so that after the death, the ant stays fixed to the vegetation, and the spores that grow out of the fungus fall to the ground and infect any ants passing by. So, to summarize, all the species of fungus I showed you today are extremely host-specific. So, in conclusion, should we, as Homo sapiens, be worried of becoming zombies anytime soon? Well, short answer is no, because these fungus have no way of becoming adapted to infecting humans. So unless someone casts a spell on us and we turn into a bug, we are 100% safe. Thank you very much.